Many people wear smartwatches for all sorts of reasons. It could be for tracking your steps, tracking how well you're sleeping, or maybe even texting your mom. But what a lot of people don't know is how the devices actually work. How can a wearable measure your blood oxygen saturation or your heart rate or your steps or sleep? Today, I'm going to tell you a little bit more about how that works. You may be wondering how these devices work to measure your heart rate. All of the smartwatches and smart rings that you may have heard of work under the same principle called photoplasmography. Photoplasmography uses an optical signal to measure changes in your blood flow that are due to changes in your cardiac cycle. Every time that your heart contracts, you have blood that pulses through your body. And that change in the pulsing of the blood changes the volume of the blood under your skin. Now, the light that gets shined from your devices can actually measure whether there is more or less blood under the skin. And that change in the amount of blood under the skin mirrors your heart rate. That's how we can use light to measure your heart rate. So heart rate is just one of the types of measurements that smart devices can make. Another common one is step count. The underlying sensor on a device is an accelerometer. And the way that an accelerometer works is it has a mechanical element that measures a change in acceleration, and that gets transferred to an electrical signal. You can think about it as if you have a weight on a spring, where when somebody moves forward, that weight on the spring moves, and then that transfers an electrical signal through capacitive plates that get put closer together. Through that transition of a mechanical force to an electrical signal, we get something that looks like a step count. There is a lot of algorithmic processing that goes on under the hood to go from that electrical signal to knowing that somebody has taken a step. When you're taking a walk, your wrists swing back and forth. You can imagine that there's a motion that happens there that can actually be transferred into an electrical signal. You can combine information from heart rate and from movement to bring them together to learn about somebody's sleep and know when somebody is in a certain stage of sleep, how solid their sleep has been that night, if there's been a lot of restlessness. So that's just one example of how these measurements can be used to learn things about people's health.